Hi, my name is Zachary Dishian, and the data structure I'm going to be discussing today is the T-tree. So to start, what is a tree? A tree is a hierarchical data structure that has a root node and subtrees of parent and child nodes. So a T-tree is a data structure that is a kind of tree. A T-tree is a balanced index tree structure that is optimized for when the index and data are fully kept in memory. T-trees take advantage of the fact that the index and data are fully kept in memory and don't keep copies of indexed fields within the index tree nodes. This makes it so T-trees just use pointers to the actual data fields. The T in T-tree is referring to the node structure of the original concept first described. The data structure itself actually looks like the letter T, which is why it's named a T-tree. So a T-tree node is usually made of pointers. These pointers point to the parent node, the left child node, the right child node, an ordered array of data pointers, and control data. T-trees are a binary tree that has many elements in each node. Each node is called a T-node. A T-node is allowed to have one T-tail. This is where data pointers can be inserted. It's at the very bottom of the T-tree. A T-tail has the same structure as a T-node, but only its data pointer storage space is used. If a node is full, a tail is created for it. A T-node is considered full when both the node and the tail are full. This structure is evolved from AVL trees and B trees, which are both other kinds of tree data structures. But the T-tree is closely related to the B trees. So since T-trees are binary, they retain the binary search nature of AVL trees. And also, T-trees contain many elements, so therefore T-trees retain the good update and storage characteristics of B trees. T-trees implementations include searching, inserting, deleting, and rebalancing. T-trees can also be traversed in either direction, either front or back, and from any node in a T-tree, all their nodes can be retrieved. T-trees were once widely used for main memory databases because of their superior performance, but as time went on, T-trees became less popular and less widely used due to provisioning costs. Technology got better and T-trees just phased out over time. So T-trees actually have three different variations. They have internal nodes, half-leaf nodes, and leaf nodes. Each variation is the amount of child nodes associated with the T-node. The difference between the three is that internal nodes have two child pointers, one to the left and one to the right. Half-leaf nodes have only one child pointer, either to the left or the right, but not both. And leaf nodes have no child pointers, so no left, no right, neither. The size of the T-tree and structure dictates which node variation will be used. The internal nodes point to the most T-nodes, the half-leaf node only will point to one node, and the leaf nodes, of course, point to no nodes. So typically, T-trees were used in main memory systems and were under the C language. They are often placed on top of a self-balancing binary tree. These trees became out of balance when a node is either added or deleted. So the T-tree will then scan looking for that imbalance and then balance itself with some amount of rotations to make it balanced again. T-trees are typically used as a primary access method of main memory database systems. Of course, it used to be their main function. Now they're mostly phased out by newer data structures. T-trees once provided performance benefits over its competitors, but in recent times the T-trees have seen less use as there are now more efficient ways of doing a T-tree's job. So the takeaways from this data structure is that it is a T-tree is a kind of tree data structure closely related to AVL trees and B trees used for inserting, searching, adding, and deleting, and they used to be widely used amongst main memory database systems, but in recent times they've become too expensive to implement. Therefore, other structures have been used in its place. And they have three different variations: internal nodes, half-leaf nodes, leaf nodes. One important detail to remember about the T-tree data structure is that it has a root, and then it has the subtrees with either an internal node will have the parent and two childs, the half-leaf will have one child, and the leaf node will have none. And the T-tree is not something that will probably ever be used in our lifetimes, at least very often, because it's just been phased out. But it's important to know when using AVL trees and B trees, because knowing this information about the T tree, since they're so closely related to AVL trees and B trees, may come in handy. Thank you.